Hello VR class, I hope you're all doing well. Apologies if the audio isn't great. My headset mic won't reach all the way to my workbench, so we're having to use the webcam's built-in microphone. So in virtual reality we often talk about the visuals a lot because that's the dominant feature. We sometimes talk about audio, how the spaces sound, uh, audio design in terms of giving a virtual experience, making it feel immersive. But one of the things that's harder is physical feedback, like haptics, tactile feedback, temperature, those kind of things. Um, so we often neglect these things. Now some controllers have vibrotactile feedback built in, like the Vive controllers has. I think it's actually an acoustic vibration mechanism of some sort that can give you some pretty good feedback. Now, when you're moving through like a medium, like you're pushing through something, it'll give you like a vibration or something. But with this, you can also do things like if you've played the archery game that's built into the lab, when you pull back the bow and arrow, you get this kind of creaking in the controller that's actually pretty darn compelling. I really like that. But one thing that we don't typically get is temperature feedback. So we can reach out and we can grab a warm mug or a cold glass of iced tea or something like that, and you feel that temperature. And that's something that we typically lack in virtual reality. Well, there are ways to get that, and this guy right here is one of those ways. This is a thermoelectric cooling unit. Now, this thing came out of an electric cooler. It's a little portable thing. You put a six-pack in it, you hook it up to your cigarette lighter, or whatever we call those now, and it cools it down. Now, it's all done with this little device right here. This is actually really cool. I had one of these and it broke, and I decided to just take it apart and salvage the parts out of it. Unfortunately, this part, the part that was the important part for the whole thing, seems to still work pretty well. And now, one of the things you have to keep in mind is that you can't manufacture cold. You can manufacture heat. You can take electricity, you can take one form of energy and turn it into another, but you can't manufacture cold. In order to make something cold, what you have to do is you have to move heat from one place to somewhere else. And this guy does that using electricity. So if we put current through this device, one side will move heat to the other side. So one side will start getting really cold and the other side will start getting really hot. Now, I looked up the specs on this thing and I can't remember exactly what they are right off, but I know this thing had a 12-volt power supply, so let's try hooking this up to 12 volts and show what we got. So I'm gonna pan up just a second. This is my power supply. Gonna crank it up to 12 volts. And let's connect up our device. Okay. And panning back down. Okay. This is really cool, literally. I wish I had a thermal camera or something so you could see this. But I've got another way I can demonstrate it to you. So this side of the plate is getting really cold, like very frigid, almost icy. I mean, maybe not quite that cold, but it's getting there. While the other side is getting pretty darn hot. So all the thermal energy that was on this side of the plate is being transferred to this side. So this is pulling heat from one side of the plate to the other. And using this, you can make a surface pretty darn cold fairly quickly. The response curve isn't very steep. It kind of ramps up and ramps down. But still, a pretty darn cool mechanism. Now, you might be thinking, well, that's neat. You probably have to have two sets of these if you want to make something hot feel hot and cold. Say you want to embed this in a glove that you're going to use in virtual reality. Well, that's not the case. You don't need two of them. Turns out this thing, even though it has, your ground and your voltage, your typical colored cables, you can reverse this and it still works. So let's disconnect and swap our voltage and ground. And now the behavior is reversed. This side is getting cold, and this side is getting hot. So if you add a switching mechanism in say you're putting this in a glove or something, you could switch the direction the current's flowing through the device and reverse whether or not it's moving thermal energy to one side of the plate or the other, and then swap it around. Now, in reality, we can touch a hot mug, we can touch a cold cup, and we can switch between those sensations fairly quickly. This has a little bit of ramp up and ramp down, so it's not very quick in terms of how fast it can switch temperatures, but still a nifty little mechanism for adding some temperature to your virtual feedback. Now, like I said, I don't have a thermal camera to show you how this guy is actually changing temperature, but there's something else I can show you. This is a really cool device in that you can also put heat into it and make current flow through it. You can produce electricity by putting heat into it. So let's hook up the oscilloscope here. And yeah, there's our 60 hertz ish power line interference. It should go away shortly. There we go. Okay, let's adjust our volts per division down to about 50 millivolts per division. Okay. Now, what I want you to do is I want you to watch what happens. My hand is fairly warm. Well, it's a little cool in here, but I think for our purposes, this is going to be fairly warm. Notice that the voltage coming out of this thing is very near zero right now. But if I look at that, suddenly the voltage goes negative. And if we flip-flop it, let it return back up to ambient temperature. If we flip-flop it and put my warm hand against the other side, the voltage goes positive. So you can imagine the same kind of response curve happening when you're putting voltage into it and it's actually making heat or cold on one side or the other. So this is actually a really cool device. There are some other gloves out there that use probably similar devices to this. Some, I think, are experimenting with using hot and cold fluids. So actually pumping warm and cool water through little veins in a glove to give you hot and cold feedback. But this is a pretty nifty and pretty low-cost device. And if you ever have one of those electric coolers break down, you can harvest one of these out of it. 2 if you're lucky, but most of the ones I've seen for like little 6-pack coolers just have the 1. Okay, so we're going to wrap that up right there, and if you guys have any questions or need anything for your projects, I recently posted a video about using Spoke and Mozilla Hubs. Keep an eye on Blackboard. I'm going to try to write up a project description tonight and get that posted within the next 24 hours, so you guys can have some time to be working on that. Okay, in the meantime, if you need anything, let me know. Otherwise, I'll see you in cyberspace. Later.